We are about to understand and learn why rockets go up, and what makes a rocket go up to the space.
20 seconds and counting. T-minus 15 seconds. Guidance is internal. 12, 11, 10, 9. Ignition sequence start. 6, 5, 4, 3, 2, 1, 0.
What pushes the rocket up, Newton's third law of motion, is simply the answer, which states that for every action there is an equal but opposite reaction. So if I push on the wall with 100 N of force, it pushes back on me with 100 N of force. So why don't I move? When the wall pushes back, friction is also pushing on me with a greater force than the wall pushes me back. So overall, I don't move. The action and reaction forces are called an action-reaction pair. To understand how these work in a rocket, we're going to use balloons as a model. The size of the balloon will represent how much fuel the rocket has, and thus how big the action force is. We'll examine how this affects motion by letting the balloon deflate and push the air out. Then, measure the distance the balloon travels. The materials needed. Finally, the data table. It is where we record the datas of the balloon A and balloon B. The steps for the experiment. 1. Slide the 5 meters piece of string through the straw to create a track for the balloon. 2. Blow up the first balloon as large as it will go. Do not tie it off. 3. Attach the straw to the balloon. Put the straw on top of the balloon and use 2 pieces of masking tape to secure it. 4. Now, measure the circumference of the balloon by wrapping the string around it. Measure the string with the meter stick. Record this in your data table. 5. Now it's time to let your balloon fly. Pull the balloon to one side of the string and either secure the other side to an object or have a friend hold it. Let your balloon open and watch it fly on the track. 6. Measure the distance traveled using the meter stick and record this in your data table. 7. Repeat step 1 to 6 for the second balloon, but make it a smaller size. Now for the execution of the experiment. These are the data gathered based from the experiment. Questions. Which balloon traveled farther?
Balloon A traveled farther than Balloon B because it has more air trapped inside than Balloon B, thus provide greater thrust or forward motion.
How did action-reaction pair influence the balloon travel distance?
The air trapped inside the balloon pushes out the open end, causing the balloon to move forward. The force of the air escaping is the action, while the movement of the balloon forward is the reaction.
How do action-reaction pairs cause motion?
According to Newton's third law of motion, forces always act in equal but opposite pairs. Another way of saying this is for every action, there is an equal but opposite reaction.